Hello everyone. This is the second video of my channel. So I did not give a brief introduction about myself in the last video. So let me do that. So, oh, so my name is Samarth Kulkarni. I'm in class 11th. So I just started class 11th, and I am studying for NEET. Oh. 2026. So yeah. And now you might be asking, why am I creating these YouTube videos? Well, I learned about the Feynman technique when I was in 10th standard, and it really helped me study and memorize each and every concept. And so I'm making these YouTube videos so it might also help you. And I'm just practicing this for self study, and yeah, I'm just revising while also making YouTube videos. So let's revise what we learned in the last concept in the last video by doing some questions. So question 1, we have in 2 mole NH3 at 0 degrees Celsius 1 atm, find number of NH3 molecules. So we want to find the number of NH3 molecules at 0 degrees or 1 atm. That just means NTP. So we are given 2 mole, so we know that they're talking about NTP, that means volume. So we have to use the formula of V upon 22.4. So that means 2 is equal to V upon, no wait, sorry, it's asking us about the number of NH3 molecules. Yeah, so we have to use the formula N upon Na. So this is 6.022 times 10 to the 23. So N is equal to 6.022 is also 12.044 times 10 to the 23. So that is the number of molecules. Then we have to find the number of hydrogen atoms in NH3. Now how you do that is you multiply the number of molecules times 3, because there are 3 hydrogen atoms. There are 3 hydrogen atoms in each molecule. So that means we have to do, let's take this as 2Na. So that means this is equal to 3 times 2Na, because we have 3 hydrogen atoms in each of the NH3 molecules, and there are 2 Na NH3 molecules, so that equals to 6 Na hydrogen atoms. Now we want to find out the mass of NH3. So we're given 2 moles and we want to find the mass. We want to find the mass, which is equal to W upon M, the given mass upon the molecular mass. And NH3 we can break down into N plus H3. So that means we have 114 plus 3 times 1, which is equal to 17. So that means the molecular mass is 17U. So 2 equal to W upon 17, which is equal to 34. That means the weight is equal to 34 grams. Now we want to find out the volume of gas. Of NH3. So we have to use N equal to V upon 22.4. That means 2 is equal to V upon 22.4 because we have 2 moles. That is equal to 44.8. So V is equal to 44.8 liter. And we have revised every formula and concept that we have learned in the last video. So now let's practice some harder problems. Alright, so now we have a diagram over here, or we can draw it in two different ways. There are two ways in which we can interchange volume and mass, like find out different values. For example, if we're given mass and we are asked about volume, then what do we do in this case? So there are two ways in we can do that. So N is equal to W upon M equal to V upon 22.4 equal to N upon NA. Or we can draw a simple diagram: mass, number of particles, and volume. And we have N over here, and then mass, number of particles, and volume. So we connect these three. So over here we divide by M. Over here we divide by Na. And over here we divide by 22.4. Over here we multiply by M. Over here we multiply by Na. And over here we multiply by 20.4. So if we're given alright, let's take this color over here. If we're given the mass, then we divide by the molecular mass and we will get M. And suppose if we're asked about the number of molecules, then we multiply by Na. If we are given the volume and if we want to find suppose mass, then we divide by 22.4 and get the number of moles, and then we multiply by M, which is the molecular mass. So that is a way in order to find different values if we're given different values. So let's do some practice problems. So find volume of 16 gram O3 gas at NDP. Okay, so 16 grams. So we're given the weight as 16 gram and we want to find the volume of O3 gas. So we're given the weight. Now the first thing we have to do is find the number of moles. Or instead of doing that, we can do this instead. N is equal to M upon W upon M. We have seen this formula right here. We can use this formula. So 16. Now let's calculate first the molecular mass of O3, which is 16 times 3, which is equal to 48U. So that means W upon M is equal to V upon 22.4. So that means 16 upon 48 is equal to V upon 22.4. So that means 1 upon 3. So that means 1 upon 3 equal to V upon 22.4. Now we have to divide 22.4 upon divided by 3. So Now 22.4 divided by 3, 721. Over here 1. We will get 4s are 12, 2, 6 over here, and 7. So we will get 7.467 liters, which is equal to the volume. Now let's do the second question. Find the mass of 22.4 liter H2 gas at NTP. Alright, so we want to find the mass of this volume right here of H2 gas. So that means we want to find the mass. We have the volume as 22.4 liter, and we can use the formula, and the molecular mass is H2, so that means 2 units. So that means W upon M is equal to V upon 22.4. So that means W upon 2 is equal to 22.4 upon 22.4. This gets cancelled out. That means W is equal to 2 gram. Let's do the third question. Calculate the number of H2 atoms in 2.8 liter H2 at NTP. Alright, so calculate number of H2 atoms in we want to find the number of hydrogen atoms in 2.8 liter H2 at NTP. That means we want to find the number of molecules, so N times 2, because there are 2 atoms of H hydrogen in each one. So N times 2 equal to how much? And we are given volume is equal to 2.8 liter, and Na is equal to 6.022 into 10 to the power 23. Or Na, we can just take Na. Actually this is wrong. Or Na. So we can use the formula directly that states that 2.8 liter, right? So V upon 22.4 is equal to N upon Na. That means 2.8 upon 22.4 is equal to N upon Na. Now 2.8 liter is equal to 1.4 divided by 11.2. 2 0.7s are 14, and 2 5s are 10, 2 6 are 12, 0 7 8. So 1 by 8 is the ratio. So 1 by 8 is equal to N upon Na, and that means that N is equal to Na upon 8. So this is the amount of molecules, but we want to find the amount of the number of H atoms. We want to find the number of atoms. So that means that there are 2 times of the number of atoms found in one hydrogen atom. So that means 8 Na upon 8 molecules. So that means 2 times Na upon 8, that is equal to Na upon 4 hydrogen atoms. Alright, so that is it for today. Alright, let's take another question. This is an interesting question. So 14 gram of nitrogen gas and 2 gram of helium gas were mixed together and we want to find the volume. So that means we have 14 gram. So let's take nitrogen. We have W equal to 14 gram and M is equal to 14 U. And in helium we have 2 grams, so W is equal to 2 gram and M is equal to 4 U. So let's take the number of mole equal to 14 upon 14 equal to 1. So N is equal to 1 over here, and over here N is equal to 2 upon 4, which is equal to 0.5. So that means N is equal to 0.5. So now we want to find the volume. So that means V upon 22.4 equal to 1. So that means 22.4 liter of nitrogen. So 22.4 liter. And over here V upon 22.4 equal to 0.5 moles, which is equal to 1 by 2 to 11.2 over here. So that means we have 11.2 liter over here. So now we want to find the volume of the mixture of these gases. These gases do not react, so that means that the weight will remain the same when we mix them, the volumes. So that means 11.2 plus 22.4. Oh wait, I'm so sorry. Over here we have okay, I realized I did a very big mistake over here. So over here we want to find out the we have 28 U over here actually, because we have two nitrogen molecules. So V upon 22.4 is equal to 14 upon 28, which is equal to 1 upon 2, and 22 upon 4 upon 1, so that will be 11.2 liters. So now we combine these, 11.2 plus 11.2, which is equal to 22.4. I'm so sorry, I messed that up. Over here we have two nitrogen molecules. I forgot that we have to take that number as well. Alright, so that is it for this video. Thank you.